Space Technology Hall of Fame, where tonight we recognize this year's inductees and pay tribute to over 30 years of space technology innovation excellence. Before we recognize our 2018 inductees, we must thank a group of people who play a crucial part in making this program such a success. Our esteemed panel of judges who generously contribute their time and their expertise to help select our inductees. Please hold your applause until we've recognized all of our 2018 Space Technology Hall of Fame judges. Thank you to each of you for your generous support of this important space awareness program. And now, without further ado, we honor two outstanding new technologies: high-strength, wear-resistant aluminum alloy and miniaturized laser terminal for aircraft, unmanned aerial vehicles, and satellites, technologies that are enriching and improving lives around the world.
There's two questions. Where did we come from? And are we alone? And if you want to answer those two questions, you got to explore space.
We almost take it for granted, this age-old dream to explore space that is so real and commonplace today. We build rockets, spacecraft, telescopes, satellites, rovers, space stations, ground stations. It is rocket science. But we don't have to be scientists to take advantage of it. Space technology is all around us.
We went into space to explore space, but the real benefits come back in improving life here on Earth.
To live and work out there, space agencies around the world help develop new ways of doing things. In fact, part of the International Space Exploration Mission is to develop new technologies, then transfer and license their use to business and industry.
Started out as a government type thing and is really now helping all of us, not just Americans, but people across the world.
Since 1988, the Space Technology Hall of Fame has shined a spotlight on things that were originally created to fill a need in space that we use in everyday life.
You've used space technology 8 times already today. Did you get in your car? Did you use sat-nav? Are you using your mobile phone? Have you seen a weather forecast?
But we're going to see this area of showers move east across the plains this morning as our big I'm a meteorologist, and I play one on TV too. I couldn't really do my job without using space technology in so many ways, like hyperspectral imaging, Earth measurement with the new GOES satellites, and real-time modeling. Using space technology helps predict dangerous storms and save lives. Healthcare, transportation, public safety, communications, energy, and even food, you name it, and space technology is a part of it. For over 30 years, Space Foundation has honored hundreds of organizations and individuals responsible for technologies now inducted into the Space Technology Hall of Fame. 30 years of imagination, innovation, and inspiration.
Somebody has to be the curator of those discoveries. The Space Technology Hall of Fame highlights their importance to the rest of the world.
Every year, Space Foundation considers dozens of nominations for the Hall of Fame. 2 are being inducted here tonight. One expands communications above the clouds, and the other helps save the atmosphere. Both of them started in space and were expanded into technology that makes life better for everyone on Earth. Communicating with light is nothing new. Signal fires, torches, even reflected sunlight, their use goes back thousands of years. In 1880, Alexander Bell and his assistant Charles Tainter created the photophone that transmitted speech on reflected sunlight. Bell considered it his most important invention. but it relied on the sun, and wired telephone and wireless radio communications proved to be much more reliable. The invention of lasers in the 1960s revolutionized communications. Optical fibers proved to be ideal pathways for secure, fast, high bandwidth, and long-range connections using laser light. NASA investigated free air optical communication between an airplane and a ground station using lasers in 1964. But rain, fog, dust, and heat can affect the reliability of optical connections near the Earth's surface. Fiber optic and wireless are still the go-to connections we rely on. All that's changing at light speed. Scientists and engineers working in Germany's DLR Institute of Communications and Navigation have been researching optical laser communications technology since the 1990s. With the aim of commercializing technology from this research, a group of former DLR employees founded the company Vialite, which is now Mynaric, in 2009. Since then, the team has designed and developed optical communication systems, providing ground stations and air terminals to a variety of customers. They have successfully demonstrated air-to-air communication in the stratosphere, as well as satellite-to-ground communications. Airborne Wireless Network is using Mynaric technology to build a proposed aircraft-based communications network. Google, Amazon, Apple, and Facebook all see potential in optical communication technology as well, using balloons or unmanned aircraft in the stratosphere. The Mynaric systems are well suited for these proposed aerial networks. DLR's research and the entrepreneurial spirit of Mynaric scientists could lead to a new internet above the clouds for worldwide users here on Earth. Internal combustion engines are notorious polluters. They spew out over a quarter of the total greenhouse gas emissions in the U.S. But space technology is helping to clean the air. In 1993, Marshall Space Flight Center in Alabama was one of many collaborators in the Partnership for a New Generation of Vehicles program. Ford suggested that new, lightweight, durable pistons could be a part of the solution. The challenge, however, was making them from the right stuff. Enter NASA, where scientists helped develop a solution. They realized that existing alloys would be too heavy for engine pistons, and after months of research and testing, they perfected a new alloy of aluminum and silicon called MSFC 398 Hyper-Eutectic Alloy, or NASA 398. This new material was tested in prototype engines, and while the results were good, Ford and their piston suppliers decided not to license or use NASA 398. Those at NASA, however, they knew a good thing when they saw it. They continued to refine the product, patent the technology, and search for new commercial partners. Marshall's tech transfer team talked with Bombardier Recreational Products, the maker of snowmobiles, jet skis, and high-performance boat motors. Their Evinrude engineers were designing low-exhaust improvements to two-stroke marine engines. And working with NASA, they used the new Alloy 398 to fabricate and test improved pistons that are durable and lightweight. Today, Evinrude licenses and uses this NASA technology in its E-Tech marine engines. They're fuel-efficient, long-lasting, quiet, and clean-burning. NASA 398 has proven to be an ideal material for demanding applications, and NASA continues to seek new partners. It's another example of NASA's Innovative Technology Transfer Partnerships program, working with a variety of industries to deliver the benefits of space technology to the public and private sector. Tonight, we induct into the Space Technology Hall of Fame miniaturized laser terminals. Aluminum Alloy 398. For 31 years, Space Foundation has honored hundreds of organizations and individuals who do the science, engineering, and math behind space technologies we rely on every day. 79 technologies inducted into the Space Technology Hall of Fame.
Space is just so utterly interwoven into our everyday lives, and we just need to make sure that people understand this extraordinary infrastructure right up there in the sky that is enabling all of our lives.
These are truly outstanding technologies and well-deserving of the recognition. And now, to present the organizational awards, please welcome to the stage Space Foundation CEO Tom Zellebor, along with Space Foundation Chairman of the Board, retired General William Shelton. In recognition of their innovative efforts, the following organizations are officially inducted into the Space Technology Hall of Fame for 2018. Representatives, please come up as your name is called. For high strength, wear-resistant aluminum alloy, NASA Marshall Space Flight Center, Jody Singer, Center Deputy Director, and Terry Taylor, Technology Transfer Office Chief, accepting. Evan Rude, BRP, Serge Thibault, Manager, Purchasing, and Karen Frederick, Inside Sales, Government Sector Manager, accepting. For miniaturized laser terminal for aircraft, unmanned aerial vehicles, and satellite, DLR Institute of Communications and Navigation Division, Professor Pascal Ehrenfreund, Chairwoman of the Executive Board, and Dr. Florian David, Director, DLR Institute of Communications and Navigation, accepting. Menarek, Joseph Fehrenbach, CEO, and Dr. Marcus Knapik, Founder and Board Member, accepting. Congratulations once again to you and your organizations for your truly excellent work. Earlier this afternoon at the private induction, we gave special recognition to the individuals instrumental in developing these life-improving technologies. Congratulations to all of you for the work you do, and please join me in another round of applause for all of our honorees. The individuals are the ones with their backs hunched over because the medals are so big tonight. That's how you can spot them.